Now, when you've done an experiment, if you're trying to get a certain amount of product, you can use this percent yield to give you an idea of the accuracy of your experiment, which is very similar to what we did previously with percent error. The only difference is percent error will cover you for things, for experiments where there isn't an amount of mass that you're getting at the end of it. So maybe you're looking for some sort of rate and comparing that to a rate, or maybe you're looking for an enthalpy value. So pretty much percent error is probably a little bit more universal and it'll cover everything, but it is very common obviously in chemistry that we're trying to get a certain amount of stuff at the end of it. So the other accuracy thing that you really should throw, you should have one or the other. So uncertainty propagation is needed to give us some sort of idea on the precision and the random error, and either percentage yield or percentage error is giving us some sort of idea on the accuracy and perhaps some of the systematic errors. So they're absolutely critical, these two things, for to get the top marks in your science experiment. So this is the formula. So percent yield is actual yield divided by theoretical yield. And so this is how we do it. This is a practice problem. So first you have to do a bit of stoichiometry to work out what you should have got, and then you use the formula. So in this problem here, 45 grams came out, so that's the experimental, and 42.03 went into the system. Don't have to worry about limiting reagents, that's next. So what's the percentage yield? So we have to work out what we should have got, which is in question. So we just do our basic stoichiometry there. So we know the ratio is 1:2. We know that we had 42 grams go in, so we had 1.5 moles go in. So the ratio is done here, so 1x is 2 times 1.5. So we should have had 3 moles come out. Now 3 moles gives us 51.2 grams. And you should expect with all these questions that what you got should be less because of incomplete reactions and errors and dropping stuff all over the floor. Just kidding. And so 45, yes, that is less. So now we just do the calculation. So percentage yield calculation is experimental divided by theoretical times 100. So there's the 45, there's the 51, and 88%. So that gives you an idea of how good you were. You didn't get 100%, but you got pretty close.